Good morning, students. Welcome back in chapter number 3, video number 18. In this chapter, we have seen almost all the topics, but I want to revise few important topics which are important to remember as well as which is very useful for solving numericals as well as for our board exam also. Okay? One of the topic of this chapter which is most important is which one? That is Kirchoff rules. Okay? Kirchoff's rules. Okay? There are three rules. Three rules? Two rules of Kirchoff. First rule is also known as KCL. What do you mean by KCL? Kirchoff's current law. And Kirchoff current law is applicable for a junction. Right? Means Kirchoff first law you can apply at the junction point only. What was its equation? Its equation is like this. Sum of I is equal to 0. So this is the short form of Kirchoff's current law. The statement is like this. The algebraic sum of electric current at the junction is 0. Got it? Once again, the algebraic sum of electric current at the junction is 0. Okay? Second. What is second? That is KVL. What is KVL? That is Kirchoff's voltage law. What was its equation? Its equation was like this. Algebraic sum IR is equal to algebraic sum of EMF. For what? For a loop. Okay? So, what is its statement? The algebraic sum of product of electric current passing through its resistance. Sir, please, once again. Okay? The algebraic sum of product of electric current passing through its resistance is same as algebraic sum of EMFs of a battery connected to the loop. Once again, let us see. The algebraic sum of product of electric current passing through its resistor is equal to the algebraic sum of EMFs of a battery connected to the loop. So, it is Kirchoff's laws or Kirchoff's rules. Okay? Now, second one. What is Western bridge? Got it? Have you studied this? Exact. Western bridge consists of 4 resistors. They are connected in series. So that 4 resistor, out of this 4 resistor, 3 resistors are known resistor is unknown, and this unknown resistance you can find with the help of Western bridge. Okay, in Western bridge there was a term. Which term? Balance condition. See, these are the logical questions, as well as these are the questions which is related to that practical exam also. So what is balance condition? So anybody will say you, okay, the bridge is in balance condition, then electric current passing through the bridge is 0. How we come to know electric current passing is 0? Because at that time galvanometer shows 0 deflection. Okay, and under this condition we had obtained R1 by R3 is equal to R2 by R4. Any of this, suppose R1 is unknown resistance, then make a subject R1 is equal to R2 by R4 multiplied by R3. By using this equation, you can find the unknown resistance. Okay, then we have seen meter bridge. Got it? What is meter bridge? Meter bridge, it is a compact form of Western bridge. In Western bridge there were 4 resistors, but in meter bridge there is only 2 resistors, and out of this one resistor is known and one resistor is unknown. Again, this unknown resistance you can find with the help of meter bridge. Got it? And for that we had equation, that is R is equal to, what was the equation? Try to recall that equation. R is equal to, R was unknown, L1 by L2 multiply by S. So R is unknown and S was known resistance. And here instead of L2 we have placed 100 minus L1. Why 100? Because there is a wire which having length 100 centimeter. Okay, then there was one more, it is potentiometer. What was the potentiometer? Potentiometer was a device which is used to find, what to find? Electric potential between any 2 points, and that electric potential between any 2 points is directly proportional to its length L. Right? So this is its first use. Second use. What was the second use? Potentiometer is used to compare. What to compare? EMFs. EMFs of 2 cell. How? There is a condition E1 by E2 is equal to L1 by L2. And third, what? Potentiometer is used to find the internal resistance. Whose internal resistance? Internal resistance of a cell. Got it? And internal resistance is symbolized as small r is equal to, what is the equation? Right? Okay? Then you have to refer your class note. Right? Are you writing class notes? Say honestly, okay? Otherwise, you have to find from our textbook. Got it? Now, let us see one of the most important numerical of this chapter. Actually, it is there in additional exercise, but in previous syllabus, it was a regular example, and that example can be asked for 3 marks or for 4 mark question. Okay? And this additional, it is there in additional exercise, and its number is 3.21. Okay? Let us see. Okay? There is a one network. See, check it out. Okay? First of all, I will draw the network, and then we are going to explain this numerical, how to solve it. Okay? Let us see. The network is like this. There are combinations of resistors, and that combination look like a continuous change, continuous and repeated chain. Okay? See, all the resistance are of equal magnitude. In our example, 1 ohm is given, but if the value of 1 ohm is changed, instead of 1 ohm, there will be any value. So how to solve it? For that, for our conveniency, instead of 1 ohm, let us consider each resistor R of R ohm, capital R ohm. There is a battery here. That battery having electric potential 12 volt, isn't it? And it having internal resistance of 0.5 ohm, right? R is equal to 0.5 ohm. Got it? How to solve this numerical? For that, let us see. As you know, it is a continuous loop. So, this part, you have to take as X, right? So instead of this continuous loop, you have to take X. So our loop look like this. So it is X, and this 1, 2, 3, 3 resistors are as it is. there is a battery as it is, so 12 volt and 0.5 ohm, its internal resistance. Okay, now check it out here. This X and R, they are connected in parallel, right? So for this X and R, they are in parallel combination. So for parallel combination, we know that resultant. What is the resultant? That is X multiplied by R upon X plus R. Got it? We have seen in case of 2, when two resistors are in parallel, then we have to remember upside there is multiplication of both resistors, that is X multiplied by R, to the denominator X plus R. Now our circuit will reduce like this. See, so now this is parallel combination having value X multiplied by R upon X plus R, and rest of the resistors are as it is. Now check it out. There are three resistors R, X dot R, X plus R and R. These are in which? They are in series. Okay, and for this series combination, the resistance, total resistance, that is XR upon X plus R plus R plus R. And this term you have to take, what to take? Here what we have taken? X. So this term you have to take as X. Got it? What is R plus R? That is 2R. So X as it is, XR upon X plus R plus 2R. Multiply this term on both the side. So it will be X upon, multiply by X plus R is equal to XR plus 2R in bracket X plus R. See, it is simple mathematical steps, but I am solving this numerical with the help of each and every step. Why? Because of special bio students only. Do multiplication, so you will get X square plus XR is equal to XR plus 2RX plus 2R square. So here XR will cancel out. So we will have what? X square is equal to 2RX plus 2R square. Take this both the term on this side. So we are getting X square as it is minus 2RX as it is minus 2R square is equal to 0. Okay, so this equation is, give it equation number 1. Again, there is a continuous loop, so keep any one combination and rest of the loop is taken as X, and R combination of these three resistors are same. Okay, X and R, they are in parallel. So for parallel, the resultant resistance is X dot R upon X plus R. Now our circuit reduced to like this. Okay, so this is the parallel combination. and that remaining R as it is. These two resistors and they are connected in series. So for a series, resultant resistance is given by simple mathematical steps. So this is our equation. You know very well, math students, right? So it is a quadratic equation, and for that, what to do? Again we are writing the same equation, that is x square minus 2rx minus 2r square is equal to 0. Okay, what is this? Let us take, it is a is equal to 1. What is this? It is b is equal to minus 2r, and what is this? It is nothing but c is equal to minus 2r square. Got it? Then what is its solution? We know the equation. Which equation? X is equal to minus b plus or minus under root delta upon 2a. What is delta? Delta is equal to b square minus 4ac. What is b? Put it here. That is minus 2r square minus 4 value of a, 1 value of c, minus 2r square. So minus minus plus square, 2 no square, 2 to the 4r square minus again minus, so it will be plus 4 to the 8 r square. What is this? 4 plus 8, it is nothing but 12 r square. What is this? It is delta, but we have to find under root delta, so take square root. When we are taking square root, so it is under root 12 multiplied by r square, so is equal to, what is 12? That is 4 3s are 12 multiplied by r square. So under root delta will be 4 its square root, that is 2, under root 3 as it is, and r square's root, so it is r. So this is the value of under root delta. This value we have to put in our standard equation. Okay, let us see. Minus b, that is minus b minus 2r plus or minus under root delta, that is 2 under root 3 multiplied by r, 2 as it is. What is the value of a? 1. So is equal to minus minus plus, that is 2r plus or minus 2 under root 3r upon 2. So 2 cancel out, so you will get x is equal to r plus or minus, again 2 cancel, so under root 3 r. Take r common, right? 1 plus or minus under root 3, right? You know very well, okay, here negative term do not exist, it is not possible, so you have to take its which value? Positive value only. So you will get x is equal to r 1 plus root 3 is equal to r 1 plus, what is root 3? That is 1.73. So the value of x, what is x? It is the resistance of that combination. R here 1 plus 1.73 means 2.73. Now here This is our standard equation. Now, what is there in our question? In our question, the value of R is given. What was the value of R? Check it out. It is 1 ohm. Got it? Then the same value of R 1 ohm you have to put here. But it is given. What is given? That is R is equal to 1 ohm. So you will get X is equal to 2.73 ohm. Now, what is the question? What we have to find? We have to find, determine the current, right? Means we have to find electric current, that is I. I is equal to V by R. V, it is given, that is 12 volt. R, instead of R you have to take X plus small r. Why? Because this is the value, it is for a loop. That means 12 upon value of X, that is 2.73 plus what is R? This is the internal resistance of a battery and it is given 0.5. So it is 12 upon how much? Do the calculation. You will get 12 upon 3.32 what? 3.232. 3.232. Take calculation and you will get electric current I is equal to 3.72 ampere. Got it? So this is our final answer. Isn't it? It is very nice numerical. It is there in additional exercise. Up to this exam, means last year there was NCERT exam. Additional exercise was not asked. Any of numerical of additional exercise was not asked. But if it is asked, then how to solve it? It is here. Okay, have a look. First of all, loop. Keep it last loop only. Then entire loop you have to assume it is X. Then standard equation. Simple mathematical steps. Have a look. Okay. Then, dear students, try to solve few of the numericals which you know. Okay. And whatever the doubt is there, we will solve next time, either in video or in classroom. Thank you.